Welcome, everybody. Welcome to this third webinar on the series of screening. I hope you can hear me. And I'm joined here with Karl, our screening team lead. And I myself am Kaur, product analyst in Salv. Before we kick off, I'm told that I'm not heard. Karl, can you confirm that you can hear me?
I can hear you very well.
No. At least Karl can hear me. Hopefully others as well. Can some of the attendees? Okay, nice. We have confirmation, so we can kick off. Before that, some housekeeping. As we have planned this webinar to be a kind of open seminar, then we have left some room for questions, and please ask them right away. I have a chat window open for this Q&A, and we'll try to answer it on the go. And after this webinar is over, an email will pop up to you with this recording as well. So with that in order, let's kick off. And to set the scene, I'll try to give a short overview of a situation where fuzzy matching went wrong. As you remember, in 2013, April, they were in Boston, there were loud explosions. And during a public event, terrorist acts were committed and many people were injured, some were killed. And along this investigation, they actually found that an alert for this person or the perpetrator, Tamerlan Chernayev, was actually given out, but it was missed due to a single difference in names. So there was just a different spelling of Chernayev, which is totally acceptable in many other countries, but this was missed by the border guard. And so after extremist training, Chernayev was led to the country and committed these horrific accidents. Of course, we are not talking about, we're talking about a little bit more safer side on sanction screening, but still a good example on what can happen if things go wrong. And not to kind of go into too positive side, and still I have to address the topic of complexity. So how complex the topic actually is, how small is the needle and how large is the haystack. So in screening, we have basically one data point that we have to work on, meaning the name of the person, and using that we want to see if that are these two persons the same or not. Of course, we have some auxiliary information as well, but name is the kind of the initial point, and auxiliary information like date of birth or residence is not always available. So the complexity remains. World is large. There are a lot of people. There are a lot of different cultures. There are different writing systems. So all that contributes to the challenging problem of name matching. Here is an example of how you can write Yevgeny or Eugene in different ways, and this is mainly due to different pronunciations of the single name, and some biblical names are kind of written in different forms. So for example, Juan in Spain can be Giovanni in Italy, and there are many examples of that as well, all contributing to the challenges of matching. And of course, when we write from different scripts or different alphabets, we want to transliterate into our own. Right now, we are mostly focusing on writing it into Latin alphabet. So, for example, the letter X can be written in different forms because it's pronounced differently in different parts of the world. And contributing more even is the honorifics and prefixes and suffixes. So lady, Mr., doctor, son, son, you name it, will all contribute here to the large complexity. And there are different name structures in the world. For example, how In the European setting, usually we talk about first name and last name, maybe middle name. Then, for example, in Arabic cultures, you might be given a given name. So what is our first name in our culture room? Then a father's given name, family name, ancestral name, and honorific name of a parent. For example, if the grandfather was a sheikh, then that can be also part of an official name. Name diversity. So if there's a small set of names that parents give their offspring their name, then this also contributes to the problem, because you will get one name, but you, when screened, you will get a lot of noise. So a lot of other names as well, which are obvious false positives, but you don't know it because the name is quite similar. So all the John Smiths in the world, or in, for example, Slavic cultures, Ivan and Ivanov are very popular names. So all contributing here. There is a different world of legal entity names, meaning that there are suffixes that can be abbreviated, they can be written out. And if you're not knowledgeable of that culture, then you don't know how exactly this limited liability company is in Vietnamese, or even if they have this sort of legal entity suffix. And also some names can be written out or abbreviated, acronyms can be used. So yeah. So these are the names, but also technology kind of gives in some weirdnesses. And in sense of transaction data, you're mostly given a sender name, and this quality can also differentiate. For example, it can just have initials and then a surname, or it can lack some very integral part of the person's official name, all contributing again. Outdated and poorly maintained databases. So the screening list that you're screening against can have outdated data. And also the complexities of the world come here, that if, for example, a person coming from China comes here and you ask, what's your first name? Then for them, it actually means what we take as surname or last name, because they have the name more differently. So in the databases, you can actually have these kind of cultural mistakes as well. And of course, the very obvious typos and misspellings can creep in. Algorithmic limits, meaning that even if we cramp up, or all the cultural differences might not be able to cramp up into an algorithm. And even if we could, it might not be performant. So there are bound to be false positives and false negatives. And so even with this very challenging world, we still are up for the fight, and how we do it in Salv. I will now go the word over to Karl, who will then brief you on this, how we approached it. Karl, please take over.
Yeah, thank you, Kaur. Can you switch on the slides as well, so my topic can be understood a bit better? So yeah, I'm talking how in Salv we are dealing with fuzzy matching logic. I'm seeing the wrong page, I think. So, but I can already start talking about. So in order for us to do real-time screening and real-time fuzzy matching, we have divided it into two different phases. First of them is being the search phase, and the second one is the scoring phase. And our fuzzy matching is designed to be understandable, meaning that if you start from the start going through these phases, you will understand why something comes out and why something does not come out. And we are also trying really hard to not to make any risk-based decisions for you, and not to hard code them into the fuzzy matching logic. So it's not a black box in that sense, and we have a different layer for doing those decisions. It's a clearance rules layer, where our users can define their own rules They can test it, they can fine tune them, they can find out the exact sweet spot for their business and risk according to their risk appetite. But now let's look at the first layer, which is about the search. And the goal over there is to go over millions of names and reduce it to hundreds. And in order for it to perform real fast, we have indexed those names in a way that we can calculate the Levenshtein distance on top of it. This basically means that we are counting how many edits there are in different names. And yeah, there can be like different edits, as you know, substitution or space addition or removal, or character addition or deletion, or a transpositioning can happen where one character is moved into another place than it was previously. And these edit limits can actually be calculated mathematically out, like how many edits can a name have. And yeah, bottom line basically is that the shorter name can have less edits, and the longer one can have more edits, and it will still come out. But now if we get, let's say, some hundreds of matches, then our scoring kicks in. And as this only has to deal with only hundreds of names, it can be more nuanced. And the result of this layer is tens, or actually it can also result in no matches, as our first layer is more inclusive than the second one. And more nuanced, by this I mean that it takes into account where actually these edits take place. How does it affect the sound of the name? Meaning that if you would say it out as a human being, would it be actually like a different name? Also, we do some token and phrases removal, because not all name parts are equally important. You can think of like a Mr. or Mrs. or in a company's name, you can remove like limited liability company or things like these. And the base algorithm that we are using this for is Charo-Winkler. This is also base algorithm used by OFAC. If you will go to the OFAC search page and run some fuzzy searches over there, you will see quite a similar results as in our platform. Although we have tuned our algorithm a bit, especially from Slavic and Arabic side, because, for example, sanction lists contain a lot of these names, and the OFAC one, I would say, penalizes too much edits for Slavic names. And yeah, we have one question in as well. There's a question about name order. How do you approach it? It is actually answered on the next page. Here's an example of calculating the scores for two names. So we are doing two separate things. We are calculating the composite score. So we score every token separately. This is more closer to Charo-Winkler actual logic, but we are also doing this full name score where we generate all kinds of combinations of different names. And I understand that this question is coming because well, if you have a transaction and it contains some names, then it's not guaranteed that the last name comes last and the first name first. They can come in any order. And for this reason, we are also doing these permutations and combinations and calculating scores for every case. Yep, Kaur, if you would go next to the next slide. Yeah, but the fuzzy matching and scoring only goes so far, meaning that it does not solve every problem. So what we do, we generate additional name variations. We generate the new forms for names. For example, we are removing middle names, or we are generating aliases with initials, and we are using maiden name to create additional aliases for names. And also, we are doing transliterations to have a better Cyrillic and Slavic name support. Here on the right side, you can also see like how many different ways actually you can write Alexander as well. And if you would go and try to tackle this problem only through having different fuzzy scores, then your false positive will skyrocket because you will have to set the fuzzy score threshold really low. But if we have all these names available, it means that we can also have higher fuzzy score threshold, and you can have basically less false positive matches. So this is the goal of still catching the name, but reducing the false positives as well. And to sum up, here is the flow or the funnel of Salv's fuzzy matching. So I already talked about our search and the scoring layer, but after this kicks in the configuration layer, which is configurable by users. First, we are doing good listing. This is basically a removal of already seen matches. After that, we are running rules that are configured also by users, and these are removing lots of matches as well based on the risk appetite. And as we are living in a world where the names for persons are the same, so no amount of logic or matching can clear out 100% similar names. It is possible from our platform to send out these requests for additional information to counterpart institution. And if the response comes back, we are going through the funnel again, and we are doing like a rescreening, and then we are closing the alert automatically based on the information that the counterparty institution gave us. So this is like on top of our fuzzy matching. This is the way how we are solving alerts as well. But yeah, this is about it from my side. It was quite high level, but I hope it gave already something. And now Kaur makes a small demo and shows how it works in our platform.
Yeah, just to kind of set the tone a bit. And then let's say that I'm Sergei Lavrov. I know that I'm sanctioned, and opening up an account is troublesome for me, or sending money to some other institution. So let's see if I can kind of get through this. So this is one part of our product, and let's say that I will try without the patronymic name, which is very common in my country, but no, not using those. I know that in Estonian, you can actually write my name a little bit differently, which is also very kind of acceptable in terms of law enforcement. No, still nothing. And then I know that maybe they don't know my patronymic name, so I will use it like that. Still nothing. This panel in the right shows that I'm caught. Let's try with different transliterated forms. Nope. Then I know that in Germany, they write V with a W sometimes. Still nothing. Then let's change the name order so that will not be Sergei Lavrov, but Lavrov Sergeyevich Sergei Viktorovich. No, still nothing. Still nothing. What else can I try? Let's try Viktorovich. And in Estonia, for example, we have T and sh instead of C and H. Now I got it, but I don't know if this will fly. No. And maybe they will have a little bit lower fuzzy matching score. No. Okay, so this can still doesn't work. Let's try. Maybe they're not interested in that much in my surname, but and they are maybe not that knowledgeable about patronymic names. So let's see if Sergei Viktorov will go through. So still nothing. Yeah, so all of these kind of different things can be maybe tried by somebody who's trying to avoid sanctions. And yeah, if fuzzy matching is done correctly, then it should be caught. We also like to touch upon a little bit. Okay, so there's a question that what company were you from again? We are from Salv, salv.com, if you want to check out more. On quality assurance side, so the screening engine works, but how can I be sure that making some changes or it still catches what I need to catch? So how we have approached it is that we have gathered up a representative sample of the basically names that we screen daily. And we try to be in the sense of representative of in the terms of region, the name form, how many tokens does it have, how long it is it female, male, and some other characteristics of the name. So try to kind of get the full sense of it, what's there. Then we apply some systematic fuzziness, remove characters, add characters, transposition them, remove a middle name, substitute names with initials, and some very kind of severe fuzziness as well. For example, changing letters to numbers or something like that. And then we screened against the matching data set. And since we know that what we have to catch there, so we have gathered a sample, applied fuzziness, and we now screen those fuzzy names again. So we know what we have to catch. So we can easily kind of test to catch the false negatives or try to bring that as low as possible. On the right, you can see results of this. And although, yes, might be very concerning if you see 50% of false negatives are not caught, or the sanctioned entities are not caught. But I wrote here that some fuzziness is acceptable, meaning that we have also made this fuzziness as extreme possible. So if you look at it and a person even cannot say that, yes, this is the same, this name belongs to the same person. So in terms of very high, you can see these numbers, but I'm quite sure that if you send it over to a person, they will also come to the same conclusion. But this is just to kind of test out that, okay, what are the weaknesses and what kind of things we want to tweak or tune in a little bit more so that we have a full overview of our screening engine. Then, of course, if you have real data, try to test it on that as well to see if you still catch what you caught before. And maybe if there's something new, then is it actually, should it be caught or not? So to cover it. This is largely it, what we have prepared for you. I will leave some time over for some questions, if you have any. Okay, I see. If you still have them, write them out into the Q&A. But just as a final treat for you, then I'll try to go over back to the demo system. And earlier on, we talked about that, okay, the complex world of fuzzy matching and how to write or catch the names that you want to. So this is very complex, and Karl showed us how we have made it very simple in the sense that basically you have a fuzzy matching score that you can kind of tweak your screening engine and also clearance rules. But we have made it even more complex in the sense that you can build this cultural diversity or this kind of risk appetite into your screening engine, at least using what Salv has to offer. And so, for example, here is an overview of a screening setup in my organization. And I have diversified it in such a sense that I have high-risk customers, high-risk individual customers that I want to screen, their first name and last name. And since it's high risk, then I want to bring this fuzzy score down. So I have set up here 94. Usually we see our customers using 95, 96. And I will screen them against sanctions. So we have partnered with Dow Jones to provide us with sanction lists, and also screen them against step lists and adverse media. Then I have below here individuals and medium risk customers. And for them, since they're medium risk, I can go a little bit more easier. I can relax the fuzzy matching score for them and not require so much so kind of compact screen to screen against them. And then I know that culturally, for example, my customer base, I know that I have very good data on their legal name. I have gathered it up from documents. So I get a lot of false positives from my screening because the set or name diversity is quite low in Spain. And sorry, name diversity quite low. So you have a lot of Juans, Juanitas, Carlos. So the name kind of space is rather small. And for that reason, I get a lot of hits when I screen them. But since I'm very confident in my screening screened input data, and I'm very confident in what Dow Jones and Salv has to offer, then I can actually up this fuzzy matching score even more. So to kind of counteract this cultural specifics. And I see I have another question here. How to register for this demo system via Let's Talk form? I'm sure that Lucy, our host in the background, can answer that. But the shortest way would be to go to salv.com and book a demo. I'm sure you can find it in our webpage. So this is up for this little treat that I wanted to show. Any more questions from the audience? If not, then I thank you. And this is it for the day. And have a nice day. Bye.
Okay, bye.